Assalamu alaikum. Dear students of class 11th, our topic is uniform circular motion. That is another example of motion in a plane. Motion in a plane. We are sitting in motion in a plane and we have studied the equations, how to find. And we have studied the important topic, that is projectile motion, and have done some numericals on the projectile motion. You try other numericals related to the topic. Now, uniform circular motion, when a particle moves along a circular path with constant speed, the motion is said to uniform circular motion. Now, we are familiar with the motions. The some planets are moving around the sun, or motion of a fan, motion of electrons. In uniform circular motion, speed, that the value magnitude of the motion remains constant, but the direction changes continuously. You remember that direction is given by the tangent at any point. So tangent at any point, it goes on changing. And speed may remain constant, or it may change in circular motion, but in uniform circular motion, speed is constant. Now we define some terms: angular displacement. When a particle moves from point E at time t, it is at A, and at time t, it at point B, moving along a circular path of radius r. Then we will see that the distance AB, this is called linear displacement. This is called. Now the linear displacement, the angle it forms at the center is called angular. So it is defined as the angle described by the particle while moving from point A to B in a time interval. So angle AOB is called theta. This is called angular. So it is simply angular displacement is the angle. Angular formed or described by a particle while moving from time t1 to t2. Now angle is r by radius, so theta is equal to AB by r. So the unit of angle is radian, and it has no dimensions. So we will conclude that there is a relation theta is equal to AB. You can a linear distance, that you can write it as S by R. Also linear distance is R times theta. Angular velocity, it is the rate of change of angular displacement. So omega is theta by t. So SI unit is radian per second. Diameter is m0 L0 t minus 1. We will call this as the it is similar that, so it is angular frequency. Angular velocity is angular frequency. Now consider that we can have senses from if the point E is moving in direction from A to B, that is anticlockwise, we can take the angle as positive, and if the angle moves in opposite direction from A to B, it will. Now the direction of omega, angular velocity will be, it is from A cross B. It will be A cross B, that is, it will be in a direction perpendicular to the plane containing a radius vector OA and OB. Angular velocity is equal to angle traversal divided by, so it is omega is limit of del theta by del t is equal to d theta. So it is instant angular velocity will be the rate of change of angular displacement. It is a vector quantity, and the direction is my right hand secret. The direction of the angular velocity is along the direction of the theta. When the rotation of a point object is in clockwise, then the direction of omega is along the axis of the circular path directed upwards. But if the direction of the point is in the clockwise direction, then the direction of omega is along the axis of the circular path directed downwards. So you can see, again, curl your fingers from A to B. Curl your fingers from A to B. Thumb will give the direction of the omega at O. And similarly, we will, if we curl from in clockwise, you curl the fingers into clockwise, thumb will point downwards. So that will be the direction of omega. Already you know that these vectors omega and angular theta, angular displacement, and these are called axial vectors. These are called axial vectors, but their direction is given acts upon the axis of